everyone. We're going to find the radius of convergence of the power series. So we'll get started. We're going to use the ratio test. I'm going to look at condition 1, and I know you can't see that very well, so let me write it out. The limit as n approaches infinity, absolute value of a sub n plus 1 divided by a sub n. And substitute. This is on my Facebook page if you ever want to save a photo of anything on my videos. All right, so we have the limit as n approaches infinity, and this is our a sub n. So everywhere there's an n, put n plus 1. We also don't need the absolute value sign except on the x part. So we can just write this as square root of n plus 1. And then here we have x, so put absolute value of x to the power of n plus 1 divided by 3 to the power of n plus 1. So that's this part. Now our a sub n is right here, and we're just going to multiply by the reciprocal. So this will be times 3 to the power of n divided by square root of n times absolute value of x to the power of n. Now, from there, all we need to do is take the limit as n approaches infinity. So I'm going to pull out my x's. So this is like x, absolute value of x times absolute value of x to the power of n divided by absolute value of x to the power of n. So those cancel out, and we just have absolute value of x. Now, for the 3's, same thing. This is like 3 to the power of n divided by, and this piece is 3 times 3 to the power of n. Those cancel, so we're dividing by 3. Now we're going to take the limit of our n's. So this is square root of n plus 1 divided by square root of n. So that's going to be square root of n plus 1 divided by n. If you take the limit of this equals 1. So this whole thing equals 1. So you have absolute value of x divided by 3 times 1. And just absolute value of x divided by 3. Now for it to be convergent, that means absolute value of x is less than 3. So this is convergent. I'll just put converges. And then if we have absolute value of x is greater than 3, that would be diverges or divergent. That would be if you have condition 2. So our radius of convergence is 3. So just put r equals 3. Thank you. Have a nice day. Bye-bye.